Good day to everyone. Today we are going to present about the weather-based prediction model for barbecue suitability days in Basel. My name is Emmanuel and my groupmate Dan Xiong and Xin Qing Fang also present in this video. The above points are the outline of this video. The video starts with an introduction followed by the literature review, problem statement, research question, objective, data methodology, result, limitation and feature study, conclusion, and reference.
My name is Xin Feng. Now I would like to present our project title Weather-Based Prediction Model for Barbecue Suitability Day in Basel. In Basel, outdoor barbecue are a popular leisure activity. However, because of the unpredictable weather, it is often difficult for people to plan their outdoor event confidently. To address this issue, we developed a machine learning model that can predict the ideal barbecue days based on the historical weather data from 2000 to 2010. By analyzing various weather variables such as sunshine, cloud cover, temperature, and precipitation, our model aims to grade a reliable prediction. This system is designed to help users plan their outdoor activity with greater. In the literature review, we study previous research across 5 main categories, that is problem statement, dataset, future, machine learning process, and machine learning algorithms. Firstly, researchers agree that defining good weather for activity like barbecue is complex. It depends on many factors such as physical comfort and cooking practicability. Secondly, regarding dataset, early study highlight the importance of using long-term local weather data combined with relevant variables like temperature, humidity, and sunshine. Thirdly, in terms of future, previous work showed that variables like precipitation probability, temperature stability, and wind speed are critical for predicting outdoor activity suitability. Next, about the machine learning process, it is essential to perform the proper data cleaning, exploratory data analysis, and time-aware validation to ensure the reliable prediction. Finally, the choice of algorithm also matter. Techniques like random forest and logistic regression have been widely used for their high accuracy in weather prediction tasks. We base our model on this finding, attempting to assess the specific weather pattern and characteristic on parcel. Now, I will present about the problem statement. The main problem we aim to solve is that partial unpredictable weather make it difficult to plan outdoor barbecue successfully. Weather conditions such as rain, lack of sunshine, or strong winds can directly impact the barbecue experience and even cause the event cancellation. Currently, there is no existing system that accurately predicts the weather a specific day is suitable for outdoor barbecue. Therefore, there is a clear need for data-driven decision support tools that analyze the weather data and help users determine the best day for outdoor activities. By developing a machine learning model that predicts BBQ suitable days, we provide a practical solution to help household event organizers and businesses plan their activity more effectively and confidently.
Now let me introduce our research question for this project. First, we ask, can machine learning accurately predict which days are suitable for BBQ activity based on historical weather data? This is important because unpredictable weather often causes outdoor event cancellation, especially in Basel. Secondly, we investigate which weather variables such as sunshine, cloud cover, or precipitation are the strongly indicator of a BBQ friendly day. Understanding this factor allow us to build a more focused and accurate prediction model. Lastly, we explore which machine learning classification algorithm perform the best in making this prediction. Comparing different models help us choose the most reliable method for real-world application. These three research questions guide how we prepare the data, selected the future, and evaluated the machine learning model throughout the study. Next, I will talk about the objective. Based on this research question, we set several key objectives. Firstly, we aim to build a machine learning model that can predict BBQ suitable weather days in Basel. Secondly, we wanted to identify the top weather indicators such as sunshine duration and cloud cover that influence the BBQ suitability. Next, we plan to compare the performance of different machine learning algorithms, especially random forest and logistic regression. Lastly, our objective was to crack a reliable prediction system that would help people to plan the outdoor activity more confidently using a data-driven approach.
Now I will discuss about data and methodology. The dataset we find from a table and it contains 3,654 rows with 182 columns. The time period is from year 2000 to 2010, which is the historical weather data from the European cities. The key features in the dataset are cloud cover, humidity, pressure, radiation, precipitation, sunshine, and temperature. And lastly, the target variable of the dataset is a categorical feature. So this is the binary BBQ suitability label, which means 1 is for BBQ day and 0 is for non-BBQ day. So in this page, we discuss about the methodology of the machine learning process. The first is the data loading and merging. So we will combine the weather measurements with the BBQ suitability labels, which is the target variable dataset. And next, we will inner join the two datasets based on the date column. And the next method is the data pre-processing. So the first, we will remove the duplicate rows and also we treat 0 as the missing value. And then we will impute the missing value with the median of the column. And next, we will convert the date to the date time format for the better model training. And lastly, we detected and clipped the outlier using IQR method. Next method is the EDA, exploratory data analysis. We will analyze the feature distribution and relationships to understand more better of the feature. And next, we create a correlation heat maps to understand the relationship between the feature and feature. We also based on the univariate and bivariate to do the analysis. And next is the quantify PPQ label friendly rates based on the sunshine, cloudy, and the month. And the next method we use is a feature engineering. We will standardize the feature and we use the random forest classifier to select the top predictive feature to enhance the model training. And next method is the model training. We use the 80% of the data set to train the model, and the rest of our 20% we use to do a testing. And we use the supervised machine learning classification algorithm to train the model. The first is the registered regression, followed by the decision tree, Naive Bayes, K nearest neighbor, and the random forest. And we also use the hyperparameter to tune the model via 5-fold post-validation. And last method is the model evaluation. We use the accuracy, precision, recall, F1 score, and area under the receiver operating characteristic curve to analyze the result. And we also plot the confusion matrix for the error analysis. Lastly, the ROC curve will be used for threshold performance analysis.
Now I will present about the result. First, we analyzed the skewness of selected weather future. We found that rainfall showed the highest skewness, which is 3.31, meaning it was heavily right skewed. Global radiation was moderately skewed at 0.53, while temperature and pressure future were close to symmetrical. This finding justified our decision to use median imputation instead of mean when handling missing value. Next, we look at the univariable distribution of weather future based on BBQ suitability. We observe a clear separation between BBQ and non-BBQ days in terms of sunshine duration. Higher sunshine duration was strongly associated with BBQ suitable days, while non-BBQ days clustered toward higher precipitation value. However, temperature features show more overlapping distribution, meaning temperature alone was not a strong predictor. In the b-variable analysis, we categorized sunshine into low, medium, and high groups. We found that on high sunshine days, which is more than 70% of them was classified as BBQ suitable. On low sunshine days, over 19% of them was unsuitable for BBQ. This confirms that sunshine duration is a key predictive factor for outdoor BBQ activities. Next, when we look at BBQ frequentness by month, we found that May-August had the highest proportion of BBQ suitable days, which is consistently over 15%. Meanwhile, the winter months, which is January, February, and December, had almost no BBQ suitable days. So this shows a strong seasonal pattern in BBQ suitability, with mid-summer being the most favorable period.
On this slide, we compare the 5 classification models that we evaluated, starting with the random forest. It achieved the highest overall performance with 0.89 accuracy and a ROC-AUC of 0.96. It making it our top performer for distinguishing the BBQ-friendly days. Next is the logistic regression, which delivered the second best ROC-AUC of 0.92 and 0.8 accuracy. This linear model offers a strong interpretability while still providing a solid discrimination between the classes. Here, nearest neighbors, following closely with 0.87 accuracy and 0.92 ROC-AUC. It's demonstrating that simple instance-based learning can be effective. Naive-Bayes and decision tree lags slightly behind both around 0.84 and 0.86 accuracy, yet still exceed baseline performance. So in summary, all models perform above 0.84 accuracy with random forest and logistic regression standing out. For deployment, we recommend a regularized random forest for its balance of accuracy and robustness. So in this slide, this chart shows the random forest confusion matrix on our hold-on test set. In the top left cell, which is a true negative, 495 means the model correctly identified the non-BBQ days near the event time. In the bottom right, 158 true positive show it also reliable flags good BBQ days. We only see 49 false positive days. It incorrectly marked as the BBQ friendly, and just 29 false negative and missed the BBQ opportunity. So the overall D0 and field F1 score of 0.93 for non-BBQ and 0.81 for BBQ friendly days, indicating the model is especially strong at ruling out bad days and decent at catching good ones. This result suggests the random forest is a robust classifier for our BBQ suitability task. The limitation and feature study also will be discussed in this presentation. So here we note our limitations. The model is trained only on Basel data, use a binary target that oversimplifies the BBQ conditions, and it also relies on the middle imputation that may mask the pattern of the data. We also omitted the key variable like the wind speed and UV index. Future work we will expand to multiple cities, add hourly forecast and new weather features. And lastly, the leverage a deep learning model such as LSTMs and CNN into the model training will have a better result.
Next, I will talk about the conclusion. To conclude our study, we successfully developed a machine learning model to predict BBQ suitable days in Basel using 10 years of historical weather data. Through our analysis, we identified that sunshine duration, cloud cover, and radiation are the most important weather factors influencing BBQ suitability. Among the models we test, random forest and logistic regression achieved the highest predictive performance with log AUC score above 0.93, indicating excellent classification ability. Our system can help individuals plan outdoor activity more confidently based on data-driven prediction. In the future, this project can be improved by expanding the dataset to multiple cities adding more weather variables like wind speed and UV index, and applying deep learning model for even better accuracy. Overall, this study shows the potential of using machine learning to support real-life decision-making for outdoor activities. Next is the reference that we use throughout our study. So we refer to several recent research papers and scientific articles related to weather prediction and machine learning application. This reference helps us design our methodology, choose more suitable model, and validate our findings. So that's all from my group presentation. Thank you for watching.